Hello everyone, this is your junior high school math teacher, and we will now start with the fourth grading period. And let us take the first lesson under week number 1, the 6 trigonometric ratios. Now in my first slide of presentation, we have the following objectives. So after watching the video, you should be able to recall and state the Pythagorean theorem, which is very essential when it comes to the discussion of this topic, which is defining the 6 trigonometric ratios. And if we're going to count these ratios, we have 6. But we only consider at this point the first 2. But anyway, these 6 are the sine, cosine, tangent, secant, cosecant, and cotangent. And again, we only take the first 2, the sine and cosine. And of course, you know the third objective. For our next slide of presentation, let us consider the recall on the Pythagorean theorem. Now, Pythagorean theorem states that in a right triangle, the square of the length of the longest side, or the hypotenuse, is equal to the sum of the squares of the lengths of the other two sides, in which are the legs. Most of the time, these legs are the longer and the shorter legs, okay? Now for instance, we have a figure named as right triangle CAB, this one, which is right angled at point C. Of course, we need to recall those sides from this right triangle. One is what? Okay. Now before that, for these three sides, each of these three sides are denoted by small letters that represent the length of these sides. Okay. Now, again in this figure, the right triangle, we need to recall the three sides. First is the longer one, whose name is segment BA, this one. And we know that this longer side is the opposite to the right angle C. And this side is known as what? The hypotenuse. And what about the other two sides that form a right angle? These are segment AC and segment BC. Okay, so segment AC is the longer leg, and the other leg, the shorter one, segment BC, is of course the shorter leg. So basically, the right triangle has one hypotenuse and two legs, the longer and the shorter one. Okay, and mathematically speaking, aside from this statement, we can express such theorem using symbols that represent the length of these three sides. Okay, or we could use the name of those three segments from this triangle, which is segment AB, segment BC, and segment AC. Now, mathematically speaking, the Pythagorean theorem states that AB squared is equal to BC squared plus AC squared. So if we're going to interpret this equation, it actually, this is actually the statement, no? Okay. In a right triangle, the square of the length of the longest side, which is AB squared, is equal to the sum of the squares of the other two sides, or the two legs. Now, we can also express this mathematically using those small letters symbol that represent the length of these three sides. So, mathematically speaking, we can write the Pythagorean theorem as C squared is equal to A squared plus B squared. And from this formula, we can have three different formula transformation. The first one is C is equal to the square root of A squared plus B squared. And this transformation is very useful when uh, solving or finding the length of the longest side given the lengths of the two legs. Okay. Now for the second formula transformation from this equation, we have A is equal to the square root of C squared minus B squared, wherein this second transformation is useful when solving for the length of the shorter leg given the longer leg and the hypotenuse. And finally, the third transformation of the Pythagorean theorem is B is equal to the square root of C squared minus A squared, wherein this transformation is useful when finding the length of the longer leg given the hypotenuse and the length of the shorter leg. Okay. Now for our next slide, let us have the topic, which is the trigonometry. Now the word trigonometry comes from the ancient Greek word trigon, which means what? Triangle, and metron. When you put these two words together, we have this one, the trigonometry. Now, again, when we say trigon, it means the triangle, and metron, it means measure. So basically, the word trigonometry means triangle measurement. So the measure, okay. Now the trigonometry involves the study of triangle measurement. Now let us have what we call the right triangle trigonometry. Now usually when we study trigonometry, most of the time we are using a right triangle. Okay, so when we say right triangle trigonometry, it often used to find the length of one side or the measure of an acute angle of a right triangle. Now, for instance, let us have this right triangle, and the name is triangle ABC. Obviously, this triangle is right angled at point C. Okay. Now, and let us denote the length of the three sides by three small letters. The longest side is denoted by small letter C, and the other two sides or the two legs are denoted by small letter A for the shorter leg and small letter B for the longer leg. We know that, again, recalling what I have discussed about right triangles, the longest side is the hypotenuse. Now, we know that the other two sides are the legs. Now, other than that, you need to take note that each of these legs can be labeled according to the reference acute angle. Now, what do I mean by that? Okay. So, for instance, let us have the vertical leg, the shorter leg. Segment BC, or length small letter the leg small letter A, can be labeled as what? The opposite leg of angle A. And at the same time, this leg can be labeled as the adjacent leg of angle B, since this leg is next to this acute angle B. And at the same time, this leg is non-adjacent to angle A. So that's the reason why it is the opposite side of this angle. On the other hand, the other one, which is the horizontal leg or the longer legs denoted by small letter B, can be labeled in two different ways also. The first one is we can consider this leg as what? The leg which is the opposite to, or the opposite leg of angle B. And at the same time, this leg is adjacent to angle A. Okay? Now, Now, please take note of the following labels, particularly the labels from each of these legs. We have no problem with the hypotenuse. It is labeled as the hypotenuse. Okay? Nothing else. Okay? Now, in the study of trigonometry, okay, out of these three sides of right triangles, we can form a ratio out of this right triangle. In how many ways? Actually, we can form 6 different ratio with respect to a certain acute angle. Okay, now let us read this statement. Trigonometric ratio is actually a ratio of the lengths of the sides of a right triangle. Now, along with this, you will learn the so-called three basic trigonometric ratios. And these are what? The sine, the cosine, or sin, as it is abbreviated, and cos as the abbreviation for cosine, together with tangent, or TAN, as an abbreviation. But again, as I told you earlier, we will focus on the first two. And we will consider the ratio for tangent on the next video. Okay? Now, so at this point, let us now consider the ratio of the 2 out of 3 sides of this right triangle in reference to acute angle A. Now, for acute angle A, we have the following. Sine of A is defined as the ratio of the opposite leg of angle A to the hypotenuse. Now, if we're going to use the equivalent symbol of each of these labels, the ratio becomes what? Now, for the opposite leg of angle A, that is what? Small letter A over the hypotenuse, which is labeled as small letter C. Okay? Now, for the second ratio, of course, this is our first ratio. And for the second ratio, that is cosine or cos A, but you read this as cosine of A, and it is defined as what? The adjacent leg of angle A over the hypotenuse. Now, using the symbol of each of these labels, referring to this figure, the adjacent leg of angle A is what? Small letter B over the hypotenuse, which is small letter C. Now, for the trigonometric ratios in reference to acute angle B, we have these two ratios. First one is sine. Earlier, we defined sine of angle A. This time, we define sine of angle B. Actually, the definition remains the same, but the only difference here is we are considering a different acute angle. So, this is the opposite leg of this time angle B over the same hypotenuse. So, in symbol, that is what? Side small letter B over C. And for the cosine of angle B, that is defined as the ratio of the adjacent leg of angle B over the same hypotenuse. So in symbol, that is what? Small letter A, this one, over C. At this point, let us apply what we have just learned about the first two of the 6 trigonometric ratios. Our first illustrative example, we are now asked to find the sine and cosine trigonometric ratios for each acute angle in this given right triangle. In the given right triangle, where C, which is we know as the hypotenuse denoted by small letter C, has a length of 5, and the leg denoted by small letter B has a length of 3. Now for our solution, now actually the right triangle here on the right side is given. Now your segment AB here is actually the hypotenuse denoted by small letter C, that is 5, and the given leg, small letter B, is actually the shorter leg whose length is 3. So it's obvious that the other leg, which is the longer one denoted by small letter A, has the unknown length. So how do we compute for the length of this unknown leg? Obviously, we have just recalled about the Pythagorean theorem. Of course, for our solution, we need to find first the missing side denoted by small letter A, and we use again the Pythagorean theorem. We know that the Pythagorean theorem states that what? The sum of the squares of the legs is equal to the square of the hypotenuse. Actually, we're using the equation b squared plus a squared is equal to c squared. So that is, if we plug in the value of c and the value of b, that will give us 3 squared plus a squared is equal to 5 squared. And from this equation, 3 squared becomes 9 and 5 squared becomes 25. And then transforming the equation, so at this point it becomes a squared is equal to 25 minus 9. And we know that on the left side that is 16. So a squared is equal to 16. We get the square root of both sides. We actually get two values, the positive or negative 4. But since we're talking about the length of the leg, there's no such thing as negative 4. So we only consider positive answer. So A is equal to 4. And at this point, we have now the 3 lengths of these 3 sides. So at this point, at this moment, we can now define the first 2 trigonometric ratios, the sine and cosine of both acute angles. So actually, so the trigonometric ratios, or the first 2 trigonometric ratios in reference to acute angle A, are the following. So going back to the definition of sine of an angle, particularly angle A, that is defined as the opposite leg over hypotenuse. Obviously, the opposite leg in reference to angle A. And what is that opposite leg of angle A? That is obviously this one, whose length is 4 over the hypotenuse, which is 5. Okay, next, about the cosine of A. For cosine of A, that is defined as the adjacent leg of angle A over the hypotenuse, and obviously the ratio is 3, this one, the adjacent to angle A, over the hypotenuse, which is 5. Okay, next, how about in reference to angle B? What are the 2 trigonometric ratios? First one is sine of B, or angle B, that is the opposite leg of angle B over the hypotenuse. And what is that leg opposite of angle B? Obviously this one, because this is your angle B. So 3 over the same hypotenuse, whose length is 5. Okay? Then next, cosine of angle B. It is defined as the adjacent leg of angle B over the hypotenuse. Now, if this is your angle B, where is that adjacent leg? When you say adjacent, yung leg na katabi nitong angle na to, obviously this one. And what is the length? It's 4 over the hypotenuse, whose length is 5. So that is 4 over 5. For our next illustrative example number 2, given theta, or the angular measure denoted by theta, and we know that this is also an acute angle. And this time, the value of sine of that angle is given as 5/13. Now, what would be the value of cosine trigonometric ratio of theta? Now, for our solution, first is we draw a triangle. And let us label the figure based on the given information in number 2. So, we know that sine theta is defined as what? The ratio of the opposite leg to angle theta over the hypotenuse. So, if we draw a right triangle like this, we could easily identify that this is the hypotenuse and its length is 13. And 5 compared to 13 is much smaller. So, it is obvious, it is very obvious that from the definition, it is being labeled as the shorter, the leg, which is the leg. Since the value is small, it means it has a shorter length of leg. Okay? So, between the two legs, which is shorter? This one. And what would be the length? It's 5. Therefore, this is the unknown longer leg, and let us try to denote this by a symbol, say letter X. So, this is your theta. Now, before we can define the cosine theta, we need to find first the length of the longer leg. And obviously, what are we going to apply here? We apply, yes, it's the Pythagorean theorem. Solving for the length of the side denoted by x. So what is the Pythagorean theorem? So that is x squared plus 5 squared is equal to 13 squared. So solving this equation, so at this point it becomes x squared plus 25 is equal to 169. Then transpose 25 to the right. So the equation at this point becomes x squared is equal to 169 minus 25. So x squared is 144. So get the square root of both sides so that we can get the value of x. So x is equal to 144, and that will give us 12. So the longer leg has a length of 12. And at this point, we can now define the cosine of theta. Then from the definition, cosine theta is what? If this is your theta, it is defined as the ratio of the leg adjacent to this angle over the hypotenuse. And obviously the answer is 12/13. Okay? Now for our next discussion, we have the next slide, and this time it involves the use of the scientific calculator. Okay, so calculators in degree mode or trigonometric tables can be used also to find the trigonometric ratios. Now, let us have the first example. Say we are asked to find the value of the following. Or the first one is sine of 50 degrees. Now, how do you use the scientific calculator to compute to find the value of this sine 50 degrees? Now, this is what you're going to do. In your scientific calculator, you press the following buttons. Press sine and then type 50. Then afterwards, you press the equal sign. And it will give you a value of 0.766044. Okay? For number 2, we have cosine 50 degrees, 30 minutes. Now maybe in the next meeting I will explain what does 30 minutes mean. But anyway, let me give you an idea. When we say minutes, we are not referring to the unit of time. It refers to the unit of an angle, which is actually a part or a portion or a fraction of a degree. So when we say 30 minutes, this is actually equivalent to 1/2 of degrees. Okay? 1/2 of a degree. Okay. But anyway, how do we compute for the value of cosine 50 degrees in 30 minutes using the scientific calculator? So this is what we're going to do. You press the following buttons. You press the cosine and then type 50. Then you press the degree, minute, second key. Then type 30 degrees. Again, you press the degree, minute, second key. And then after that, you press the equal sign to come up with the answer. So that is 0.636078. Now for my next slide, I'll show you these simple trigonometric ratios. Now how do we use this? Actually, when I was in high school, we don't have the scientific calculator yet. Now to find the value of trigonometric ratios of a certain angle, we use the pocket-sized trigonometric table or the logarithmic table. Now, using this presentation, I will demonstrate how to use this table. So I'll just pause the video and let me discuss the application of this. Now actually the discussion on how to use this table will not be included in this video. Okay? Because this one is intended for classroom discussion. So at this point, I will end the discussion from this video and we will see you next time.